Hi, okay. In this part of the course on thermal physics, we're going to start looking at specific heat capacity. That's one of the main thermal concepts. We will be looking at how to calculate energy changes involving specific heat capacity, and this will involve the use of the data booklet equation Q equals mc delta T, where Q is the heat transfer. So what we're dealing with here is the situation where a substance, and specific heat capacity refers specifically to a substance, has heat transferred to it. So energy is transferred. Q, measured in joules, is transferred. And that will result in a temperature rise. Although specific heat capacity, I should be very clear about this, also describes the reverse situation. In other words, how the temperature that's transferred out of the substance also relates to the temperature drop. So Q, we're talking about heat transfer, temperature rise. If a substance, and the substance has a mass, m, and the change in temperature, delta T, will be proportional to the amount of heat that's transferred, but it is also inversely proportional to the mass of the substance, and that's logical. If we transfer the same amount of energy to 1 kilogram of water, then it will produce a smaller energy change than if it's half a kilogram water, and greater energy change than if it's 2 kilograms of water. But it also depends on the material. The same amount of energy transferred to water, liquid water, and transferred to alcohol will produce different amounts of energy. The only limitation when we're talking about specific heat capacity is when we're talking about a substance, we're referring to a particular chemical, compound, mixture, element. It could be any of those things, but also in a particular phase or particular state. So we're just talking about liquid water, and the specific heat capacity of liquid water is going to be different to the specific heat capacity of ice. The specific heat capacity of iron, we're only talking about solid iron. If we're talking about liquid iron, it would have a different specific heat capacity. So continuing there, delta T is proportional to Q and inversely proportional to M and depends on the material. So therefore, we introduce the C, the specific heat capacity, as the measurement or the description of the material. It's the constant of proportionality, and we write it, if we're keeping our equation looking the same as it just did, delta T is proportional to, as 1 over C, Q over M. And if we rearrange the formula slightly, we get that to C equals Q over M delta T, which is the definition of specific heat capacity. In words, the energy in joules required to raise the temperature of 1 kilogram of substance by 1 Kelvin or 1 degree C. Because it's a delta T, it makes no difference if we're talking about Kelvin or degree C when we're talking about specific heat capacity, because it's delta T. So C equals Q over M delta T, where C is specific heat capacity in joules per kilogram per Kelvin, or degree C. Q is the heat transfer in joules, M is the mass in kilograms, and delta T is the change in temperature in Kelvin or degree C. So for example, suppose we transferred 500 joules into a substance, and the mass of that substance was half a kilogram, and the change in temperature was 25 degrees C. It went from 0 to 25, or it went from 50 to 75, or it went from 40 to 65, whatever, delta T. By rearranging that, you will actually find that the C, if this is water we're talking about, equals 4,200 joules per kilogram per Kelvin. It's actually a little bit less than that, 4,180 or something like that, I think, but 4,200 is good enough for us. So that's how to find the specific heat capacity of a material. That equation is actually generally written, as is shown in the data booklet, in terms of Q rather than in terms of C or delta T. So Q equals mc delta T. So Q is the heat transferred, and then that will you can rearrange that formula to find, well, you can use the formula to find what value of Q is required for a given mass, a given substance, and a given change in temperature, or you can rearrange it as you wish to determine what you need to find out. Before we finish, that specific heat capacity refers to a particular substance, but it's always, if you look in the units, in terms of kilograms. Okay. In other words, what will 1 kilogram of that substance do? Obviously, the actual heat capacity, it refers to a particular object, given mass. So, for example, instead of talking about just 1 generic kilogram of water, we could be saying, what is the energy of this rather nice looking swimming pool? Not a very sunny day, but it's still a very nice looking pool area. So that particular arrangement of water, that particular mass of water, will have its own heat capacity, and that's given. Heat capacity is giving the symbol C. Rearranging that formula, C equals Q over delta T. So it's just the energy needed to rise the temperature of that mass of water, or that object, or that Volkswagen, or whatever, by 1 Kelvin or 1 degree C. Okay, thank you very, very much.